All right, hello Washington Eagles. It is Tuesday, May 5th. It is math time, and I suddenly realized, I don't know if I said this yesterday, but this is our last full week of distant learning, and I'm kind of sad about that, even though I don't see you all. I really enjoy doing this. I still wish we were in class getting this done, but unfortunately we are not. But again, we got to stay safe. Here comes Leo. He's going to help with fractions today. So yesterday I asked you all to represent a third and show me what 5/10 would be. And so if we were to do a picture of a third, so remember our denominator is our whole. So we have to turn this into a, oh, that's terrible. Oi. So we have to turn this into a third and somehow make it look kind of even. So here's our three parts, 1, 2, 3, our denominator. And we're shading in one part of that 3. So here's that one part of our 3. So this is now 1/3. All right, so if we were to do 5/10, well, how many parts are we going to shade in of our tenths? Oh, 5. We're going to shade in 5. So 1, 2, 3, 4, 5. Yeah, there you go, 5/10. All right, let's keep it moving. Now, I have to clean off this board. This blue doesn't erase very well. Leo, you're on my work, man. Okay, so we're going to show different ways of representing fractions today. We're going to erase our numerator and our denominator. So you all should have that down, that the denominator is our bottom number and our numerator is our top number. But I'll leave up the whole and the parts of the whole, okay? Because sometimes it's hard to remember that. So, because we hear numerator and denominator all the time. And, you know, sometimes it's hard to remember, oh, what is the denominator? Oh, yeah, it's the whole. What's numerator? Numerator, it's parts of the whole. So now we're going to be representing different ways of representing fractions today. So, we're going to start with a third, okay, just because it's in my book and is kind of fresh in your mind, okay? So here we have a third. And there are different ways that we can represent the third. We can represent the third by a picture, which we've already done. We've already done a picture, but here it is anyhow. And we can represent on a number line. And how many parts? So 0/3. And now we have to divide this into 3 parts. So 1, 2, 3. And here's 3/3. So 3/3 equals 1. That is equivalent. Or 3/3 is equivalent to 1, is what I should say. And so if we were to do a number line, we're going to just do how many hops? 1 hop. There it is. 1/3. There it is, 1/3. Now we're going to, oh, we can't decompose that one. So now we're going to, here's what I'm going to do. I'm still using this number. We're still using a third. So now we're changing this to 2/3. Now we're changing this to 2/3. So now we have 2 parts of our whole shaded. And how many more hops are we going to make? 1 more hop. So now here's our 2/3. Our 2/3. Okay, now we're going to decompose this number just a little bit, okay? So if you recall, our denominator is going to stay the same. It almost always stays the same, but we're not going to worry about a different denominator for now. We'll worry about that next year, okay? So right now we're just saying that our denominator is going to be 3, and we're going to decompose this. So what we're going to do is we're going to say 1/3 plus 1/3 equals 2/3, okay? So whenever our denominator is the same, it will stay the same here in our answer, but our numerator is going to change. 1 plus 1 is 2, and so now we have 2/3. So this is another way to represent 2/3 is by adding, okay? So let's try another one. Let's do another one. We're going to do, I'm looking in my little book, my little handy dandy book. Let's do 5/8. Okay, let's do 5/8. We do 5/8 yesterday? I think we did. We're going to do 6/8. Here we go. So in order to draw this out, we got to have 8 parts. Here are our 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to shade in how many? 6. You're right. We're going to shade in 6. I'll use a different color. So 1, 2, 3, 4, 5, 6. So here's our 6 eighths. This represents this, and if we were to do a number line, how many parts are we going to do? We're going to do 8. So 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I made that really long. I gotta double check my work. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So this is 0 over 8, and this will be 8 over 8, or 1 whole. How many hops are we going to make? 6. You're correct. We're going to make 6 hops. 1, 2, 3, 4, 5, 6. 6 eighths. How many hops? 1, 2, 3, 4, 5, 6. How many parts do we have? 8. If we are going to decompose this, we can say, how many ones can we have? We're going to have, 1, 2, 3, 4, 5, 6. Now, our denominator is going to stay the same. It's going to be 8. How many are we adding? 1, 2, 3, 4, 5, 6. We have 6 eighths. And we could always do like 3 eighths plus 3 eighths. 3 plus 3 is 6. Our denominator is going to stay the same. Or you could do 2, 4, 6. This is the same. These are all the same. 6 eighths. Okay, so that's called decomposing. We're decomposing those numbers. And you can see if we were to make this, let's add another one. Let's add another eighth. Well, what will this become? Well, now we're at 7 eighths. And we'd have to shade in 1 more. And we have to make 1 more hop, 7 eighths. Now, I'm going to erase this. So now we have 7 eighths. Okay, so I'm going to say 7 eighths plus 1 eighth. Well, what are we going to do? What's going to be your answer? You're right. What's 7 plus 1? 8. And our denominator is going to be 8. 8 eighths. 8 eighths is, oh, our whole thing is all shaded in. 8 eighths is 1 whole. So here we go. 8 eighths or 1 whole. Okay? If this were 100, 100 over 100 is still equal to 1. Okay? Because remember, fractions are part of a whole. Okay? So, yeah, fractions are part of a whole. So right now we have a whole. We have a whole, and, all right, I'm just going to end it at that. All right, so that's our whole. So we're going to do one more. Before I get off on another little tangent. Let's do 7. Let's do it over 7. So let's say 5 sevenths. All right, so we're going to draw a picture. Again, this is not going to be even. My parts are not going to be even. So y'all going to have to just bear with me. So 1, already, off the bat, terrible. Okay, 1, 2, 3, 4, 5. Wait, I got to squeeze 1 in. Okay, we're pretending like this is even. Okay, sorry guys. So we have 1, 2, 3, 4, 5, 6, 7. Okay, I know it could be better, but it's just not. Okay, so how are we going to represent 5 sevenths? Yeah, we're going to shade in 5 parts of that. You are correct. So 1, 2, 3, 4, 5. Okay, there is our little picture. Now, if we're going to do a number line, we're going to divide it into how many parts? 7. You're right. 1, 2, 3, 4, 5, 6, 7. Woo! 1, 2, 3, 4, 5, 6, 7. Look at that. So remember, 7 over 7 equals 1 whole. You're right. So how many hops are we going to make? 5. Here we go. 1, 2, 3, 4, 5. So 5 sevenths. This is where we're representing using a number line. Now, we're going to decompose it. How do we do that? Here we go. We're going to write 2 different ways of writing 5 sevenths, okay, by decomposing. So we're going to say 4 sevenths plus 1 seventh. All right, what's 4 plus 1? 5. Is our denominator going to be 14? No, don't you do it. Don't you dare do it. No, never. There you go. Let's do one more way of decomposing our 5 sevenths. So we can say 2 sevenths plus 2 sevenths. Or now we're at 1, 2, 3, 4. How many more sevenths do we need? Yep, we need 1 more sevenths. So 1, 2, 3, 4, 5. So we have 5 sevenths. Okay, so that's called decomposing. That's another way of representing 5 sevenths. And that is all for today. And I will see you next time. Love you guys. Bye.